So when we are starting with a rational expressions, I can then look for the non-permissible values from the denominator. I don't want this denominator to be 0, or in another word, if this denominator is 0, if this denominator equals 0, we will end up with the non-permissible value, the value that you don't want to use for the rational expressions. Solving for x, like how you solve a regular equation, moving the terms to the other side and isolate the x. This is the non-permissible values for your x. You don't want to use this value for this rational expressions here, because when you actually have 3/4 for your x, it will turn the denominator into 0, making the whole thing undefined. And that means sometimes we actually want to say x cannot be 3/4. Sometimes the denominator may look a little bit complicated. They may give us a trinomial, they may give us a difference of squares, they may give us something that involves GCF, and you want to solve those expressions like usual. For the next one, when I see a trinomial, this denominator will give us the non-permissible values if this whole thing turned into 0. Knowing how we are dealing with a trinomial, we will try to factor this trinomial and based on the 0 property, we will end up with two values that will make this denominator into 0. If you are using -3 for x, substituting -3 into the denominator, into the x, it will turn this denominator into 0. Or if you use x equals 4, put it into this and that, it will also turn this denominator into 0, making the whole thing undefined. And therefore, we don't want to use -3 for your x. We don't want to use 4 for your x. These are the non-permissible value for your x. When it gets to rational expressions and non-permissible values, sometimes we use different names. Depends on which book you're reading or which example you're looking at. They may call these numbers the undefined values, the non-permissible values, or simply the restrictions for the rational expressions.